So we start our lecture. This is today is December 30. So we have three more times for this class. So it's 1 second. And this one will be you will demo your in January 13th. You'll do demonstration. But in January 20, I will teach you the YOLO V4. Okay. So it's up to you. You can just visit the web, internet, but still I will teach this one. Okay. So 13 will your final project demonstration. So we have 1, 2, 3 more weeks to teach you the lecture. So what will I try to teach you? Can you see or not? This is we already teach it the net, and today I'll finish the AXNet, and then we'll teach VGG16, and then ResNet. After ResNet, so all four are the very basic of the deep learning backbone. Okay. And after this, one more is ResNet, right? So all four are the backbone for the important backbone deep learning. And then I will teach you faster RCNN, this one, mask RCNN, teach you YOLO V4. So I hope I can finish all the lecture and up to YOLO V4. Okay. But the lecture, we continued last week. We continued the AXNet. So for the AXNet, right here, the AXNet is a 5 by 3. Right? We have five convolutional filters, right? And then we have 3 layers for the classification using MLP, the regular neural network. So it's the same as the net. Difference the difference is the net only two major layers. Okay, but here is the 5 major layers. So I draw it this way, 5 plus 3. And the purpose, because this X is also for the classification, also for the encoder. It's a backbone. Okay. And what will we try to teach you about AXNet is so this is previous with this is the net. Okay. And the net is important one is the convolution. And also they have a crossover convolution. This one. And for the AXNet, because we have more layers, that's meaning our parameters increase. The number of parameters increase. So okay, we will face the problems, overfitting problems. Okay, so we need to try to solve the overfitting problem. So how can we solve the overfitting problem? There's 2 ways. One is that we need to do the data augmentation to increase the data. The second is try to reduce the number of parameters. So they use the dropout, try to reduce the total number of parameters. Okay, so this here they use drop out. So that's a major purpose for the, major technology for the AXNet. Okay, so here, second, the COM is probably the first one to talk about learning, the convolutional learning. So we have one block, two block, plus 3 layers. But for each block, we need to consider the crossover. So it's crossover situation. So let's crossover situation. Okay, that's meaning the filter. The filter is not only 2D, but the filter cannot say 3D. There's not 3D filters. It's 2D filter, but it's include crossover. That's meaning you have X, Y, and times number of channel. But it's not 3D. 3D filter is you have a X, Y, and Z, or WH and the depth. Okay, and crossover is for the channel, number of channel. So this is 2D times channel number. This channel number. Okay. If 3D will be 3D and times the channel number. So for the 2D, each one is a map, 2D map, and crossover number of channels or number of maps. If 3D, each one is a cube. It's XYZ or WHD. That's cube. 3D 是个 cube. But you have many cubes. So it crossover is the cubes. So if 3D is W times H times D and then times number of cubes. So 不要把2D 跟3D 不要搞混了。Okay. So this is what we teach you about the COM. And for the downsampling, we want to do the here downsampling. And I said downsampling usually have 2 methods. One is pooling. The second is straight. Pooling or straight. Just regular is two methods. Okay. And for the pooling, like this one, original, they were 4x4. Suppose image size 4x4. And if you do maximum pooling, that's meaning there's 2x2 because you want to reduce downsampling by 2. So your filter size or maximum pooling size is 2x2. So each 2x2 window, you pick up the maximum value. So this 4x4 become 2x2. That's downsampling. And why it select the maximum value is because the higher value, higher feature, feature value is meaning is good feature. 它特征比较明显嘛。Higher value is meaning they have a good feature. So let's select it. Actually, in the other way, -3 actually is also a good feature. You know the edge detection. You're positive, you're negative. So positive maxima, negative also is minima. Both actually is a good feature, but in this case, most of the maxima pooling, not most, I think all the maxima pooling only select the maxima value. They ignore the minima value. So is that the right way? Probably not. But do we have a better way? That's a research topic. So far, I did not see anybody solve this problem. Okay. And the other way is a maxima. The other way is to do the average value. Okay, so average is good or not good, depends. So most of the cases, maxima is better than average value. But average has one problem. What kind of problem? If your average value becomes 0, that's a problem. 0 is no feature. So originally you have a feature. After you do average value, it has no feature. That's a problem. But sometimes we still do the average value. Okay. And the other way, so this strike, we call this strike is 2. Right? Strike 2. Because it's 2 and then strike the other 2. Strike 1 just means drop. You skip 1. Strike 2 is skip 2. And this one, you suppose is strike 1. So before it's 4 by 4 becomes 3 by 3 because each 4 you have one value and then only shift 1 pixel. You only shift 1 pixel called strike 1. Shift 2 pixel called strike 2. Okay. So that's the pooling. So pooling have an average pooling, has a maximum pooling. And that's we just mentioned. So what we learn from the accident, one is this one. The second one is overfitting problems. So we try to solve overfitting problems. One is do the data augmentation. 你把资料增多了。Original you have only, I say, originally suppose you have 2,000 images, and then you can increase 10 times. 增加10倍嘛，上次我提到you can increase 10 times. Okay. And the other is that we try to reduce the number of parameters, and drop out is a good method. Okay. And those things is we try to overcome the overfitting problems. Because it's overfitting. Overfitting is meaning you don't have enough data. So you optimize, you have a best optimization result. That's meaning you want to, for each sample, you want to fit each sample using a best optimization method for training. But that's not good like this one. Okay. But if you underfitting is also not good. This will be a straight line. So we try to overcome the underfitting and overfitting problems. Okay, so we need to try to increase the number of data, and hopefully we can the best fitting. So we allow some error. Okay, actually in this one is only one curve we call regression. Regression curve to fit the problems. Okay, and fit this one. Sometimes it's kind of like a classification. Okay, so later on, people try to solve and improve this method using what? Using margin, MARGIN, and margin, MARGIN, right? Margin 就是一个 a little boundary between positive and negative, a little margin. And the concept of margin is from supportive vector machine. Margin is meaning here they have a small margin, so they will allow. Okay, they try to push away positive and negative. Try to push away, have a small boundary, so it's margin. Okay, so you want to have a margin. What can you do? That's meaning your loss function need to plus one more term. That term is for the constraint term. So not mean square error. Not only cross entropy. You need to plus one more constraint term. That term can increase the margin. Okay. Here, how can we do the data augmentation? So like this way. The easy way is just try to flip. But here you cannot flip upside down. It's weird because it's the dog. Okay, so it depends. You should see the situation. Not all the situation you can do. So see, in if your situation is that right, you can left to right, but that's fine. Up and down, sometimes you cannot. So one become two. Originally, you have one image become two images, and then for each one, you try to crop. So suppose original is this 256 times 256, and you will find why some input image is 225。你会发现，因为我们一般影像是256、512啊，那为什么有时候我们在做深度学习，怎么变那个好像224吧？为什么 ？Why 224? Because they do the crop. So this small window will do the crop one top left, top down, and right top right, and right bottom, and the middle one. So one image it can become 5 images. And flip again, so it becomes 10 images. You can do that way. This is augmentation. There's only one way. And then you also can change the lighting, change the RGB value. Or you can from RGB transfer to HSV domain. Because HSV, the V is the lighting. So you can change your lighting. Or you can change RGB, just change a little bit the color. But usually we don't do that. We don't do that way. Usually we do is just change the lighting. It's better not change the color. Change the color actually is no good. 你不要把那个颜色改掉，那实际上不好哦。For example, your skin color is our skin color. You change the skin color, that's weird. So you can change the lighting by HSV, the V value. V is the lighting. So you can transfer to HSV, change the V value, and then transfer back to the RGB. That's the other augmentation method. And here, Axneter say, you can do the PCA to create more images. That's correct. Because PCA can do reconstruction. So this equation, we already teach you the PCA. So this average value. Okay. And then this is a eigenvector. And this eigenvalue. So you just change the eigenvalue and reconstruct back to the other new image. So it's kind of a GAN gain. So at this time, AXNet, the GAN is not good, not so popular. In this year, why not they do GAN? Because at that time, GAN is not good enough. So they use PCA. But right now, GAN is better than, it's better than PCA. So people, you want to increase the number of image you can use the GAN, okay, instead of the PCA. But the physical mean is almost the same, the mean value and eigenvectors. And then you use change the variance, actually is the eigenvalue. Okay, sorry, it's the eigenvector. So that's for the data, the image augmentation. The next one is we try to drop out, and drop out is very important. Almost you need to use this one, drop out. It's not only drop out is not only overcome the overfitting problems. It can optimize the parameters. Drop out also can optimize your parameters. 就抓到很重要，抓不是只是让参数减少哦，它会帮你那个优化那个参数的结果。所以你在做 training 的时候，应当是都会用到 drop out。那 drop out the value, what's the percentage? as my student do, they do the 50%. So 50% is a good percentage. Okay. Dropout, what's the dropout? Dropout is meaning each time, suppose I drop out 50%, suppose if 1,000 parameters and it drop out 50%, it's meaning you idle 500 parameters. Okay. And just allow the other 500 parameters to learn, to keep learning, to keep updating the parameters for each epoch or each iteration. Okay. So dropout actually is just for this iteration or this each epoch, you just frozen these parameters. 就把它冻结住 or 冻结 meaning disconnect. And you update the other 50% parameters. Okay. Like this way. So drop out like this way. You frozen this one. Not delete, not remove, no, you frozen, 就冻结它。冻结就是 I write this one. Okay. 冻结是 doesn't update the parameters. In this time, in this iteration. So that you look like it will this way. So more thinner. Okay. And this will get a better result. Now let's for the training. After you do the dropout during the training, for the test, you will all the cells, okay, all the parameters will use. 你在测试的时候是所有的参数要全部都要用到哦。So test has no, we don't need to use dropout. So training we do dropout. Training we do dropout. But for the test, we do the fully connection without dropout. Okay. And you don't need this. Actually, you don't need to care about this one. So this page is not important. Okay. So others is just test the result. I think you can check it by yourself. Okay. So that's for the AXNet. We'll continue next one. And we talk about VGG 16. So we already have a talk about AXNet here. We talk the net, and we talk about VGG. And right now, don't use AXNet because AXNet is not deep enough. So right now, if when you do the back, here is backbone. Backbone, you can use VGG. You can use ResNet. How about GoogleNet? Not many people use GoogleNet. But if you only use for the backbone classification, it's fine to use GoogleNet. But if you want to do decoder, when you need to apply the decoder situation, probably it's not good to use GoogleNet. 就是说你在只做分类用的话 ，GoogleNet 很好用哦，结果也不错。但是你要有牵涉到用 decoder 的话，就要把它解码回来的话，那个 GoogleNet 可能不好，目前没有看到人家用的。OK， 大概跟你讲一下这样子。 OK， 那 but GoogleNet the important thing for the GoogleNet is the inception concept. So inception is important. Not GoogleNet. Inception is important. So I will mention my inception later. So what will we learn from the VGG? So VGG is important. So VGG here, VGG is a very, because AXNet already deep convolution network. So the first famous, we say famous deep learning is the AXNet because they have 5 blocks or 5 layers. Okay, but VGG16 he already called very deep. So after VGG16 we don't care about the deep， 因为 VG 它已经称为 very deep 了，所以不要再讲什么 very 不 very 的，之后就不讲这件事情了。OK， 那 VGG is a this famous author is Discrimination， 那个 Oxford 的教授，这个很有名。这 VG 那时候就很有名 ，VG very famous one。AXNet is University of Toronto。Toronto they do the Hinton they do the AXNet。Alex 是他一个以前的学生名字吧，现在可能是教授学者吧。他是 Alex。OK，Alex 是他一个人的名字哦。那个3个作者的第一个作者是 Alex， 最后一个作者 Hinton， 那个很有名的，看起来很老的很有名那个。好 ，So back to here。OK，so what will we learn the VGG? The first one is the VGG here. VGG is deep. They have 16 layers, and actually there are 5 blocks, and plus 3 layers. The same. VGG16 have a 5 blocks, actually it's 13 plus 3. AXNet is 5 plus 3. 5 plus 3, and VGG16 is 13 plus 3. VGG19 is 16 plus 3. 都是最后都是 3 layers is a neural network for classification. Okay, so VGG16 has a 13 layers, but 13 layers have a 5 blocks. 5 blocks meaning 5 downsamplings. And we'll take so here. I will go back to teach one page by one page, but here just give you a global idea. So it's VGG16. Okay. So because this is very deep, that's meaning our parameters increase a lot. So how can we reduce the parameters except the data augmentation, right? Except the dropout, but that's not enough. So what else they can do? They change the filter number. So AXNet has a 7 by 7 filters. VGG16 is 3 by 3. So even though they have more layers, but their filters, the filter size, they change it from 7 by 7 to 3 by 3. So AXNet is a 3 by 3, or almost all of them are 3 by 3 filters. And they will reduce a lot because 7 by 7 is 49 parameters for each filter. And 3 by 3 just 9. 7749嘛，然后33得9差很多诶。所以这里就 reduce. So this VGG16 actually reduce a lot of parameters, even though they have more layers. So this is the first contribution here. Okay. The second contribution for VGG16 is the input image. They have a multi-scale input images. 它输入的影像哈，一张影像而已哦。它输入的 size 会做 scaling，size 会不一样。 这个可能你们大部分都没有注意到啊，就是 input image size one image they rescale to different size. Different size is sometimes smaller and bigger, and normalized to the same size 224. They do crop. For example, suppose it's a dog, right? And they do the zoom in, zoom out, but based on the center, they crop to 224, and then for the input. So your input, the object has a different size. So they do this kind of process. Okay, this their second contribution. The third one actually is here. They'll tell you about moment. They'll tell you about that. Drop already talked about that one. So learning rate and moment. That's gradient descent. For the gradient descent, here they talk about the learning rate, adaptive learning rate. They talk about moment. Okay. Yeah, I think that's a contribution for the AXNet. The first, I say again, first one is a 3x3 filters. The second one is the input image size. They do different scaling. So the input now for each time input one image, but one image with different scaling. So they're different, probably suppose 3 different scales. So one image on 3 scales, 3 different scales image, and then input 3 times. And then final output is average. The third one is they consider they try to improve the gradient descent. Okay, we go back here. Okay, so we talk about this one, VGG. Okay. In page 7, so this is VGG. So many people use this one. Okay, so when you see this one, you can see this actually is VGG 16. And the red one is the maximum pooling. So usually, sometimes people say maximum pooling is 1 layer. Okay, but sometimes we don't call it the layer, just downsampling. So when you count, actually doesn't matter too much. 这不用太在乎这个事情了。但是通常我们在那个downsampling都不讲那个叫是一个 layer 了。So for example, VGG 16, if you ignore the red one, it's down maximum pooling, you will count 1, 2, 3, 4, right? 5, let's see, 5, 6, 7, 8, 9, 10, 11, 12, 13. So they have 13 layers, and plus 3 connected layers, 3层嘛 for classification, and 3 for classification, 13 for extraction here, and they have 5 maximum pooling for downsampling. Okay, here the filter size all are 3x3. They do strike 1. Strike 1 is meaning you don't have a downsampling. They do padding 1. Padding 1 meaning for each image outside boundary, you have 1 more 0 outside. So that's meaning after you do the convolution, your image size doesn't change. Okay, so here, 这个你自己要注意一下哦，这个是一种你最好你不熟的话，你最好一开始要养成的习惯，因为这个都是all the parameters you need to input to the Python, you to key in. Okay, so they have a lot of parameters here. Parameter 那么多。Okay, and talk again. Their their filter size change from 7 by 7 to 3 by 3. This first one. Okay. And then they use redo here. So for each block, they do convolution. They also use redo. Redo is what? Redo is the activation function for nonlinear discrimination. Right? Redo is activation function. So what's the purpose for activation function? It's a nonlinear discrimination. OK， 所以它一次分类嘛，是稍微分类一下，一次稍微分类一下这样子啊。But however, recently people use this one， 是我昨天写的，昨天晚上写的。People use convolution, they use batch normalization, and then use renew. Recently, people use this one. 好，放大让你看一下。Recently, even though it's a BGG 16, probably people use it included batch normalization inside sometimes. 这你自己注意一下哦，就是说最近有这种趋势，是以前是 convolution 加 renew 这样一组嘛，那最近是有时候会加 batch normalization 一组这样子。为什么？因为它去 normalize， 那我后面会讲 normalize 零到1之间，或是mean 是0了，然后那个 balance 是正负1这样子。So this become important, but you don't need to try anything. Just you should make sure if you need. Depends. If you need, you can use this one. So what will I try to say is sometimes you can use the same structure, the same network, but what you can do is you can change some of the network. Okay. And red one is maximal pooling. And this one is a fully connectional. That's a neural network. Okay, so here. And finally, suppose in this case, they will have 1,000 classes. So finally, they do the softmax. For the final one, they do softmax. Okay. So here's the other way to describe, to write this table, the other way to write this network. And this one is important. Sometimes you should learn. Some paper use this one. Some paper just show you this one. And some paper also show you this one, but this is better. This meaning what? For example, this means the first one convolutions, second one convolution. So this one, 1, 2. So it's 1 and 2. And this is filters. This is filters. Okay. And then do downsampling. So remember, this one method talk about your network or architecture. This is second method this is for the filter. And this one is the other way to describe your architecture. So you have one way, second, and third. But usually here, we don't talk about the filter size. Here we talk about the image or map size. 这个我们通常讲 map size 是在这里。And here's filter size. And here's also filter size. So either way, you try to describe. If I ask my student to do this one. And the image size, map size, also do this one. Or this one, either way. Okay. So here, what is this one? This meaning in first one, you have your filter size is 3 by 3. and total have a 64 filters. 64 is meaning you have a 64 3x3 convolution filters. That's meaning your output has a 64 maps. So here, 64 maps here. 这个你要会看哦。哦，这个你要会看。And pooling is maximum, sometimes maximum pooling. So maximum pooling here, rate 1. So downsampling. So here, again, what is this one? This one will be after downsampling. So it's rate 1. So after downsampling, your image size become, I think it's actually from here. Also, the same is 64. This one is the black one. This one is the black one. So here, original is 224 by 224 by 3. 3 channel is RGB, 3 channel, RGB 3 channel here. Okay. And then after you do this kind of filter, you become 224 by 224 by 64. So the first layer, second layer, the output all are 64. See, 64 filters, 64 filters. And this problem is not clear. What do I mean not clear? You see this filter is 3 by 3, right? And output, a total is 64 filters. And here is tell you is what? Tell you is more clear. This meaning you have 3 by 3 filters times 3 channel crossover. So this is crossover, 3 channels. And total has 64 filters. This filters for the first one. Second one is the same. Your filter size is 3 by 3. However, previous first one, previous you already have 64 maps. So your crossover filters is 64 channels. So your filter is 3 by 3 by 64 channels. Here is not easy to see. And this way is easy to see. So this 64 is meaning crossover. 那我希望像我要求学生要做是要画这个，这样你才真的了解。因为 because your code when you do the coding, you need to write this one. Okay, and then total 64 filters. So your filter size is 3 by 3 by 64 crossover channels. And then you total have 64 filters. So this is your total parameters. 这样子。可以哈。Okay. So this the same. So you can see from 64 channel become 128 and double. Okay. And then finally, from here to here is this one. So final output, the image size is 7 by 7 by 512. Here, the last downsampling. The output of last downsampling is, or maximum pooling is 7 by 7 by 512. This image size, but total has a 512 maps. Okay, this is the other important one. People already prove actually 7 by 7 is too small. Okay, so people sometimes don't do this one. They feel we need to have a 14 by 14 by 512. So sometimes they ignore this one. Okay. So recently people don't do this downsampling. They use it here. It is 14 by 14 by 512. Or the input size, because right now the PC is more powerful, or GPU is more powerful. So right now the input size probably will be double of 224. So the output here is 14 by 14 by 512。注意一下哈，现在很多觉得7:7太小了哦，就是已经那个已经就是7:7已经把整个影像压缩的变很小了，资讯都几乎很多都没了，这样子啊，意思是这个意思。好，那 so here is a fully connected, so they will do flatten, F-L-A-T-T-E, flatten， 就把它拉成 1D 的 flatten，然后都 fully connection。那这 flatten 参数很大哦。If you do flatten here, your parameters is 7 by 7 by 512, so they have a lot of parameters. So if you do 14 by 14 by 512, even is larger. But right now, computer is okay to process this one. I say the GPU is okay. Okay, so they flatten here and fully connected to the 4096. And total, and then find out 这两个嘛，2层，然后 final output is 1000 classes. This final output 这样子。So VG16 is become, I think, something like the prototype of recent deep learning. 这已经是一个雏形了哈，最近的那个 deep learning 都用这个雏形。OK， 所以这个表格你要自己学会，不要逃避了哈，这个没办法，你就要看得懂这个在写什么。好。So why 3 by 3 filter is better than 7 by 7 filter? Why? Because they will reduce a lot of number of parameters. So here, so suppose this is 7 by 7. So this is suppose your image size is 7 by 7. So if your filter is 7 by 7, you'll become here. Result output is 1 by 1. And here's number of channels or number of maps. So suppose number of maps is 64. So here is 1 by 1 by 64. Okay. So it's 7 by 7. And they'll count the number of parameters here. If you use 3 by 3 filters, after this one, your image size will reduce to 5 by 5. And one more time, 3 by 3 become 3 by 3. And one more time become 1. So 7 by 7 by 7 can use 3 by 3 filter to replace. And they prove the parameter is much less than that. Why? Easy, because you see this 7 by 7 is 49. And 3 by 3 by 3 is 27. So it reduced a lot. 7149嘛，那339那个3个9327就27个，就参数减少那么多，这是一个 channel 而已哦。OK， so we take a break. We'll continue to talk about this one.